we're going to do these problems. And just like last time, if you found these problems really easy, that's great. You can skip this video if you don't need it. But we'll go through each one of these two problems. Now we're going to take one at a time. We'll find the limits both numerically and graphically of the g of x as x goes to 0 here, and then of this h of x as x goes to -5. All right, so let's take the g of x first. So g of x is equal to sine of 3x over x, and we want to find the limit of that as x goes to 0. Now, when you plug in 0, that x is approaching, you get an indeterminate form, or the indeterminate form that we're seeing in this section of 0 over 0. So evaluating the function doesn't actually help me out. I just get 0 over 0, so an indeterminate form. But with limits, I can still find the limit. So let's approach 0 in both directions. I'll be 1/10 over 0 and 100th over 0 and 1,000th over 0. And then I'll do 1/10 under 0, 100th under 0, and then 1,000th under 0. So I'll do it that way. And once again, I'm not going to show the calculation of plugging in -0.1. You can do that on your own. By the way, one thing I want you to do before you start this, so that we're all on the same page, is make sure your calendar is in, or the calculator is in Radian mode, so that we're not dealing with degrees here, we're dealing with radians. That's especially important when you talk about trig functions. So anyways, plugging in -0.1 gives me 2.955, et cetera, et cetera, et cetera. Plugging in -0.01, I get 2.99955, and et cetera, et cetera. I'm not going to round it to any more than that because that's what my calculator is currently rounding it to. 0.001, we get 2 point, lots of nines, and then a couple of fives. When you plug in 0.001, or excuse me, let's do 1/10 away first. So let's start with the 0.1 first. I get the exact same thing on the other side. When you type in and you're 100th away, once again, 2.99955. And then when we're 1,000th away, 2.9999955. So while plugging in 0, the output of the function does not exist. You can see that as you get closer to 0, the function is tending towards 3. It looks like it's tending numerically towards 3. So we would say the limit of g of x is equal to 3 as x approaches 0, obviously. Now, I graphed this function already. This function has a graph which looks like this in the black. And you can see that as the x value, as you ride along this curve, and the x value is getting closer and closer to 0, the y value is getting closer and closer to 3. So as you ride along this curve and the x value gets closer and closer to 0, the point gets closer to here, So the y value gets closer and closer to 3. All right. There's technically a little hole in there, but it doesn't graph the little hole. It doesn't show up on mine. So that's, again, confirmation that the limit of g of x is equal to 3. Let's take h of x. So h of x is this rational function. And once again, if you plug in the number that we're looking at the limit towards, if you plug in this case, -5, you're going to get an indeterminate form of 0 over 0. So what we can do, well, -5, let's come from underneath. So -5.1, -5.01, -5. And then from above, when I say above, I mean from right to left on the x-axis. So there you go, I'm a 1/10 away, 100th away, 1,000th away on each side. So let's plug in -5.1. I'm just going to plug in all of these. -5.1, we get 0.70299703. If I plug in -5.01, I get 0.700297. If I plug in -5.001, I get 0.7033. Again, I'm just rounding there. But you see here, you get 1 0, 2 zeros, 3 zeros. You can imagine if you were not 1,000th away, but if you were 10,000th away, you'd get 4 zeros in between the 7 and the next number. Now on the other side, -4.9, plug that in, you get 0.6969697. Again, that's rounded. 0.699699. 0.6, none, 2, 3 nines, and then a 7. So you can see, again, each time you're adding another 9 there. So you're getting closer and closer and closer to 0.7 as you tend towards -5. So as the x value tends towards -5, the function value tends towards 0.7. All right, that's the idea. So even though you can't plug in a -5, you can, in fact, find a limit for that. Well, the graph of this rational function looks like this. And if we're tending towards -5, we're tending that way. I can hopefully zoom in on that. As my x value tends towards 5, you can see here, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So it's going right there. Each of these little grid marks is a 0.1, a 1/10 of a unit. So there you go. Yeah, 0.7 right there. So as the graph goes this way, the point is traveling towards the point -5, 0.7. So in both cases, we had an indeterminate form of 0 over 0, but in both cases, we found that the limit existed. All right, so we had an indeterminate form, but we found the limit existed. And that's the main point of this example.